Hi, this is Christian, and I'm going to talk about the general code structure of our app, FLUX. So FLUX, as an Android application, has many complexities. This is because Android is complex by nature. However, certain intricacies can be mitigated by the proper use and setup of an architecture model, and I think writing an Android application the proper way, and not the easy way, was important to this class since it is a software engineering class, and our code should reflect that fact. So in our case, I implemented the industry-recognized MVVM, which stands for Model View Model Pattern, to structure the application so we can successfully separate business logic from the UI logic. So our application made use of Room, which is an Android library that serves as an abstraction layer over the SQLite database to handle local data storage. Several tables were created to cache data that was fetched from our API calls, and the local data was used in conjunction with ViewModel and LiveData, which has served us to display the data changes in real time to the user. So ViewModel was used with several fragments as well to achieve data persistence across configuration and navigation changes. So the code I worked on also made use of advanced Java techniques such as the singleton pattern, which allows us to create a single instance of a class and provide global access to the other calling classes through this single instance over the life of the application. And this has served us greatly to prevent memory leaks. In our case, it was also used, or rather it was used to ensure that only one instance of the database class was used through the life of the application, as well as a single instance of the reminder helper class. Furthermore, I applied a factory pattern with certain ViewModel classes to make use of constructor dependency injection. This allowed us to use the application context and additional parameters such as the user's input of their canvas token, which they type through the user interface of our app, which is then needed to make API calls through the repository layer of the MVVM pattern. And this is how we passed the input to the repository layer. Moreover, I used a single recycler view under the custom calendar to display data from two different lists, which took a bit of work as I had to ensure that my recycler view adapter dynamically picked a layout according to the class type of the object to be displayed. So once the user tapped on a day of the month, the goal was to display both assignment objects and task objects on a single recycler view list. Also made a class that consists of many static helper functions to help manipulate dates and keep our UI classes lean, since these date manipulation functions were made use of quite extensively. I also implemented several portions of the UI's design and logic, including dark mode, the creation of a custom calendar for the dashboard that consists of a recycler view in conjunction with a grid layout to create the days of the month dynamically. I ensured that we used Android's Jetpack navigation components to navigate through our fragments and achieve a single activity entry point with multiple fragments on the application. Our data was also passed between fragments through the usage of Safe-args, which is a plugin within navigation components.
In this project, I work on connecting our app to the internet, specifically to Instructor Canvas. Canvas is an educational platform that stores all the coursework of a professor or student. My objective here was to allow students who happen to have access to Canvas to be able to pull their assignments into our app. I managed to develop the connection to Canvas via REST API. I use asynchronous HTTP requests to obtain the classes the student is currently taking, and then extracted each assignment and quiz description and due dates. The first challenge I faced was to learn enough Java and Android to perform any coding. I had not explored Android or Java on my own. This project presented the opportunity for me to get started on those. After doing some prep work and research, I felt confident enough to set up the asynchronous requests by using Volley. Volley is an HTTP library provided by Google and Android. Because we're not a company, we can only connect to Canvas by using tokens. Tokens are like a password, but for apps. It is up to the user to obtain a token from his account. There is a place in the settings of the app where the student can enter his token. The field for the token has some basic validation to make sure the student enters a correct input. The first thing in the project was to ensure that our app had and requested access to the internet. Then I used Volley to create a synchronous GET request, which allows the app to obtain a response from Canvas API with the corresponding data. The first GET request acquires the classes the student is currently taking. If that is successful, I use that information recursively to get all the assignments and quizzes for each of the classes. A challenge I found was that sometimes the API will say the student is taking a certain class, but in fact the class may be over or has not yet started, so the information is restricted. For that reason, I added exclusions in the code to prevent problems when there is no access to those classes. Another challenge I found was the need to parse the data response that comes from the API. Canvas API responds to my requests in a serialized format known as JSON. This data format is well known, so I use another Google Java library called JSON. I use JSON to deserialize the information provided by the API. By creating some classes for each category, and with the help of JSON, I was able to organize and correctly parse all the information. If the requests fail due to a bad internet connection or Canvas API being down, nothing wrong will happen. In fact, the user will get some feedback if the requests don't go through. In this project, I managed to pull all the classes, assignments, description, quizzes, and due dates. All that information is saved in the database and gets properly updated when needed.
For our project, I worked primarily on the model view ViewModel. Essentially, I handled the database design and working on the code for the database. The simplest aspect of the database was the settings model. Here's where settings for an individual user are handled. Most importantly, the Canvas sync frequency, which dictates how often an API call is made to update the various assignments to be inserted and or updated within the database. For example, if a professor changes an assignment, these pull frequencies will make it so that gets changed and you don't have the wrong information. In addition, the user access token is stored here, which is what is needed to actually perform the API pull. The next part I worked on, which was the backbone of the databases, was actually storing the information from Canvas. Before I began, Claudio completed the API aspect of getting the data from Canvas into our environment. Without the work he did, there would be no databases. From there, I worked on connecting the raw API data into our databases. All the problems I faced were due to the limitation of the Canvas API, which lacks some data which would be useful. For example, at the beginning of the project, we wanted separate database tables for things such as discussion boards, assignments, tests, and quizzes. However, the Canvas API does not offer a way to differentiate between the various types of assignments, so we had to settle on the following tables. Our course table, which is where each course the user is taking gets stored, which is an important required table since without a course you can't properly get the quiz or assignment. Assignment, this is where every type of assignment gets stored that is not a quiz or a test. And then finally our quiz table, which is where any quiz or test gets stored. From there, the assignment and quiz have a foreign key relationship to the course, so we know what course they actually belong to. While we weren't able to completely differentiate between the various types of assignments, the distinction between a quiz and an assignment does allow for some customizable ability, such as setting different notification settings between the two. For example, a simple assignment may only need a notification a few days before the due date, where with a quiz, you may want a notification a week or two before so you know to start studying. Overall, I am pleased with what we were able to accomplish with the Canvas API requests and fitting them into the databases. Ideally, it would have been nice to further separate assignments to more specific subfields to allow for even more personalized notifications and give the user a little bit of a better experience. If we had more time for the project, I would have considered parsing the JSON data even further and hopefully being able to figure out an algorithm that could somehow differentiate between the different type of subtasks.
This is the Pomodoro study timer implementation within our FLUX app. Creating the UI was pretty straightforward as we'd already decided on our color schemes and our general theme. So all that was needed to do was how to best figure out how to best follow through the seamless blend of that vision within an alarm. We decided on a simplistic design centered around 4 buttons to make the experience as simple for the user as possible. After a lot of headaches, rewriting code, logic, and user validation cases, we decided to start from scratch and scrap specific inputs as that should not be necessary. Therefore, we only gave the user a play button that updated to a pause button when clicked and vice versa, a stop button, and a switch button. The logic involved an update, pause, and resume function that updated the image to a pause or resume drawable button based on a Boolean variable that changed if the timer was running. The reset button destroyed the timer and reset it back to the beginning, while the study or break switch button utilized a check change listener that updated a Boolean variable based on whether it was the user wanted to study or take a break. The next big problem problem faced in writing the code and logic was updating and displaying the progress to the user. This was accomplished by creating a text view and progress bar variable that was updated via an update progress bar timer function that divided and converted a global milliseconds left variable to seconds displayed. This process was started by a start timer function instantiated as a Java abstract object class called countdown timer class, and was then progressed by a public onTick method that used a milliseconds left until finish parameter to then update the timer and its corresponding UI until the timer's completion. When done, another public method on finish is called. That method then calls an alert function that plays a ringtone and vibrates the device. It calls a change timer type function that determines the current timer, whether it's study or rest, then switches to the opposite and sets the milliseconds left accordingly. Lastly, it sets the progress bar and begins the next timer iteration to be study or rest. One of the biggest challenges was figuring out the logic to update and define the progress bar for both studying and resting. We had a problem where the bar would simply start with 1/5 of the way done when the rest timer was called, and it made for quite an unsightly UI. After going back to our trusty fundamentals and using a flow diagram to trace the logic out, the study or break timer listener was placed on the onStart function, and when clicked, it reset the timer, which was implemented by a function that destroyed the timer, changed the global milliseconds left variable, and then updated the timer progress, as well as the pause and resume button.
Hello, it's Angelo here, and I wanted to talk about notifications and notifications in the FLUX app. I worked on the notifications, and the problems I faced were few, but there were some real roadblocks. I was tasked with developing a notification backbone for our application FLUX. This notification backbone consisted of a notification channel, notification manager, and an alarm manager. I struggled at first because I was new to Java and Android entirely. A few of the problems included not having enough knowledge to take advantage of the plethora of libraries out there, such as the one I used, Alarm Manager. Another issue I had problems with was dealing with our database. Although this was not because of the structure of the database, but it was simply because pulling and making alarm objects proved to be a greater challenge than anticipated. The biggest challenge was probably dealing with alarm manager objects, as I just mentioned, which are used to create reminders using the alarm manager import class in our application. This is due to the specific way the alarm manager functions, which creates a need for many subclasses so that it is able to create reminders from the database, as I mentioned before. The issues mentioned were overcome, thankfully, with the usage of making functions for the database objects or variables. For example, one of our functions is able to extract assignment due dates and also assignment class names and types of data referring to that class and the assignment, and there's a function for each one of those. And this all allows for easy creation of a reminder object when taking the time from this extraction, and also autofills the information needed. The result was a reminder system that is able to set the time given from Canvas or manually. And this allows the user to set a reminder for whenever they want, whether a minute or a few days from their current time. The system also imports the time from Canvas token integration, which automatically creates reminders and events based upon the data database receives from the token. Going into this project, I wanted to accomplish a notification service similar to the likes of Canvas for a mobile application, and I think all in all, I was able to accomplish the creation of the notification support of the FLUX application, the capability to be able to handle, create, and set reminders using our database. It isn't quite as good as the Canvas notification structure, but it is able to handle dates integrated from tokens and set manually, which is what I was aiming for going into this part of the project.